In this lecture, we will be discussing about the various aspects of fold. So what is the fold? A ductile deformation of layered rock that forms a wave-like structure, and these structures are called folds. So here we can see a very big fold. Now we'll discuss about the various elements of the fold. First of all, the inflection point. The point in the limb where the curvature changes its direction is known as inflection points. Next, what is hinge? It is the point of greatest curvature. Next is what is hinge line? The line which formed by joining all the hinge point, or say the line of greatest curvature, is called hinge line. And what is axial surface? The surface which contains the hinge line of all the folded layers. Next is what is fold axis? The imaginary straight line parallel to the hinge line, and this is only applicable in the case of cylindrical folds. So now let's see some of the folds. So the fold which has a straight hinge line is called cylindrical fold, and the fold which have curved hinge line is called non-cylindrical fold. So here we can see the axial surface could be planar or curved. So what is interlimb angle? The angle between four limbs measured in a profile section is known as interlimb angle. So now let's see some of the more folds. Here we can see some wave-like structure. The portion of the fold in which the limbs dip away from each other is called antiforms. So here we can see three antiforms. Now we'll see the synform. The portion of the fold in which the limbs dips towards each other is called synforms. Here we can see two synforms. Now we will consider the relative age of the strata. Let's start with the horizontal bed. Here O represents the older, Y represents the younger, and arrow represents the younging directions. After the folding, if the younger rock is in the core, then it will form a syncline, and if the older rock is in the core, then it will form an anticline. So these are some of the example. This is upward direction antiform, because the young direction is in the upward direction. This is upward facing syncline because young direction is in the upward direction and it is in synform. And this is downward facing antiforms. Here young direction is in the downward direction, and this is downward facing synform. Here young direction is in the downward direction. So let's see fold based on the dip of the axial plane and plunge of the hinge line. Okay, so this is how the plunge of a hinge line varies from 0, which is horizontal, to 10 to 30 to 60 to 80 to 90. So if the plunge of the hinge line ranges between 0 to 10 degree, it is known as a horizontal fold. Then up to 30, it will be called shallow fold. 30 to 60, it will be called intermediate fold. 60 to 80, steep, and 80 to 90, vertical fold. So here we can see the hinge line is horizontal, so this is a horizontal fold. Next, in this figure we can see the hinge line is vertical, so this is a vertical fold. So now let's see the fold based on the dip of the axial plane, but hinge line keeping the horizontal. So here we can see in the first diagram the hinge line is horizontal and axial plane is vertical, so this is upright horizontal. Then in the second figure, uh, hinge line is horizontal but axial plane has some dip, means it is inclined, so it is inclined horizontal. In the third figure, the axial plane is horizontal as well as hinge line is also horizontal, so this form a recumbent fold. So based on the dip of the axial surface, we could have recumbent fold where the dip of the axial plane would be near horizontal, ranging from 0 to 10 degree. Then we will having inclined fold where the axial surface will range from 10 degree to 70 degree. And finally upright fold if its axial surface has a dip 70 to 90 degree. Now let's change the both the dip of the axial plane and plunge of the hinge line. So in this case we can see the axial plane is vertical but the hinge line is plunging, so this is upright plunging fold. And in this figure we can see the axial plane is inclined and hinge line is plunging. So this is inclined plunging fold, and in this case we can see the direction of the hinge line and the axial plane is in the same direction, which means this is a reclined fold. So based on the interlimb angle, the fold has been also classified in the various types. For example, if the interlimb angle is up to 10 degrees, it will be called isoclinal. If it ranges from 10 degree to 60 degree, it would be tight, and 60 to 120 open, 120 to 180 it would be gentle. So now we will see the deep isogon. So if you see the folded layers, we could have the inner layer and outer layer. So in this layer actually dip changes. So isogons are the line that connect the same dip. It has been seen that these deep isogons basically in the inner portion converges, diverges, and sometimes it remains parallel. So the folds in which the deep isogons in the inner portion converges, those are classified as class 1 fold. If these deep isogons are parallel, then those are class 2 folds, and if the deep isogons are diverges in the inner portion, then these are class 3. Now we will see in detail. So we have to take care of about the hinge and limb thickness. So in class 1 fold, the deep isogon converged in the inner portions. But at the same time, in class 1A type, the hinge would be less thick than limb. So that would be a class 1A fold. And in class 1B fold, the thickness of the hinge and limb would be same. So this is a parallel fold. The next is a class 1C fold, where the thickness of the hinge would be greater than the thickness of the limb. So next we will see class 2 folds, where the deep isogons are parallel. So here the hinge are thick and limbs are thinner. So these form similar folds. And the class 3 is the deep isogons diverges at the inner point, where the thickness of the hinge would be greater than the thickness of the limb. So these are the class 3 folds.